My name is Roman Pickl. My Twitter handle is rompick. I'm a technical project manager at Elektrobit, which is an automotive software supplier. I use Jenkins since 2012, and I really love CI, CD, and DevOps. And the reason for that is that I not only have a background in computer science and electronics, but also in business administration and production management, and I really love how the ideas of lean management get applied to developing software. I'm here to learn, and I've already learned a lot today, so let's see how it proceeds. So, the main question of continuous delivery is, how long does it take you to bring a change of one line of code into production? And the main idea behind that is to make releases a non-event. So you automate the implementation of your build, deploy, test, and release process. And we heard today, just before my presentation, or before this one actually, that it's not, that it takes a journey to do that. So it's not, you're not flipping a switch and it works, but you really have to invest into that. So you have to set up a system and change your culture that you can say that every change results in a build, so every commit triggers a build. Every build is a release candidate. So for example, you have to make sure that your software artifact does not depend on the environment. And then delivery can be done at any time on any environment. For that, you set up a deployment pipeline which provides visibility, feedback, and control. And I put up a bunch of books up here that I really enjoyed reading. One is Continuous Delivery. I think it's from 2010. Lean Enterprise, the Phoenix Project, the DevOps Handbook, and the new one of Nicole Forsgren, Jess Humble, and Jean Kim, Accelerate. What I also really loved is the one from Gary Groover, which is called A Practical Approach to Large-Scale Agile Development. And it describes how HB transformed LaserJet, future smart firmware. And the interesting part about that is that it's not your typical web application or a cloud service, but they really achieved to use continuous delivery in a firmware hardware setup. So read these books if you want to know more. In this continuous delivery book by Jess Humble and Dave Fowley, I think it's from 2010, they come up with this deployment pipeline. So the idea behind it is, and we've heard about it today already, that you have a delivery team. They program your app or whatever. They check in a change into version control. This automatically triggers your build and unit test process. And for example, here in this first instance, it fails. For example, because they forgot to check in some code, or they didn't run their tests locally, or a problem with the setup. And it's really important that this fails very fast. So it should take less than 10 minutes for your build stage to provide feedback to your developers. So they get the feedback, they make the change, they say, oh, okay, I forgot to check this in. They check in again, the build gets triggered. Now it's successful, and it's getting to the next stage. And we also heard about this one today. So automated acceptance tests are done. They fail again, feedback to the developer, they fix it. And then in the end, it's successful. They check it in, it gets triggered. It gets triggered by the automated acceptance test. Then, depending on your setup and whether you do continuous delivery or continuous deployment, there's a manual approval step. You do some acceptance tests and then release it. And this is presented in the continuous delivery book, and I really wanted to know how it's possible to build it with Jenkins. So my question is, who set up such a deployment pipeline in the room? Can you raise your hands? Okay. Who's using Jenkins for that? Okay. quite a number of people. Who's using Team Foundation Server? Okay, almost the same. GoCD. Sorry, say again? TeamCity. Okay. Or a software as a service solution like CodeShip. Anyone? Okay, like 4 people. So I'm talking about Jenkins today, but actually it doesn't really matter about your tool. I think most of the tools on the market can today provide you such a solution. So Jenkins is the #1 continuous integration delivery server, at least that's what they claim. It was created by Koshuke Kawagashi. Its initial release was 2005, it then was called Hudson. It's open source. It got quite an active and independent community. There are like 170,800 active installations and more than 1,600 plugins. And since Jenkins 2.0, which was released in April 2016, pipelines are first-class citizens. So before that, there was like a built pipeline plugin where you could visualize your pipeline based on existing jobs. But now with 2.0, they have pipeline as code using something they call Jenkins file. And not only that, but they also now have a new user experience, which is called Blue Ocean. And it comes with a pipeline editor, which is quite nice. So if you install Jenkins or start it from the Docker image, it welcomes you with this screen and asks you to create a new pipeline. And you have to do 4 steps to do that. First, and it's a wizard, so you're guided through this process. First, you select the type of your source controller, for example, GitHub. And I use this here. Then I provided my access code, which organization I belong to, and then chose my repository. And then it automatically looks if there's already a Jenkins file in your repository. And if not, it asks you to create one. So let me tell you something about a Jenkins file. So a Jenkins file is written in a Groovy DSL, so it's a domain-specific language. And it usually resides in your top-level folder, but you can change that. It describes your pipeline, and there are additional benefits if you store it in your SCM, for example, in Git. Because now doing that, so having pipeline as code, or treating it as code, allows you to do code review and iterations. You have an audit trail, so you know who changed your pipeline, and you have a single source of truth. So if anything happens to your Jenkins server in this case, you can rebuild it from your repository. It supports 2 syntaxes, but they can be mixed. They started with something they called scripted pipelines, which is quite powerful, and I'll come to that in a minute. But they now also have declarative pipelines, which are easier and the new style of doing it. And they started with that in 2017 and released 1.0 in February 2017. So the Jenkins file usually looks like that. On the left-hand side, you define on which agent your pipeline should run, so which nodes of your build server. Then you define stages, and all of these stages, for example, your build stage has steps. And you can transfer files and results between these stages. So as I mentioned, there are 2 different ways of doing it. There are scripted pipelines and declarative pipelines. The scripted pipelines give you a lot of control, so you can have if and else statements. You can define when a node should be allocated, but you also have to do your own error handling, so you have to deal with try and catch, for example. The declarative pipeline is way easier, and the difference here is that you start with pipeline, so it knows that's a declarative pipeline. And the declarative pipeline is simpler, more opinionated. It's more similar to your typical way of how you would click together your job in Jenkins, in the Jenkins GUI. It also allows for a validation in the visual editor, and it limits what is available to the user, but hence making it simpler. But both use Groovy, the Groovy DSL, the same pipeline subsystem underneath. They mostly use the same steps, and you can use shared libraries with both, and I'll talk about this in a second. And they can be mixed using the script step. The script step takes a block of a scripted pipeline and executed that in a declarative pipeline. So it's like a useful escape hatch. So you start with your declarative pipeline, like here on the left side, and then you cannot do any if or else statements in Jenkins, for example, but if you use the script in the declarative pipelines, I meant, but if you use the script step, you can escape out of this limitation and then use the full Groovy, or more or less the full Groovy language. But I want to mention that the script of non-trivial size and or complexity should be moved into shared libraries, and shared libraries are a place where you can put your function in and use them from different pipelines. So okay, I want to walk you through a pipeline, a declarative pipeline in this case. So you start with the pipeline tag, then you can define the agent on which it should run on. You can also define triggers, environment, options, tools, and parameters for the whole pipeline. For example, here I defined that the SCM should be pulled every 5 minutes. I also defined options to say, okay, if the pipeline does not finish within 60 days, then it should stop. I keep the last 30 builds. I store the stashes of the most recent build. Stashing is a way in the Jenkins pipeline to store files in one stage and unstash them in another stage. And if you preserve stashes, then you can rerun parts of your stages. And I skip the default checkout, which means that I do not check out in every stage. So then you have stages. For example, you have the build and unit test stage. I say in this case, it could run on any agent, but of course it could be a specific one of your slaves, or even a Docker image that should get started if you set it up correctly. Then you can also set up your tools. For example, it should run on, it should use Java 1.8 or something, or Java, I don't know the new numbering scheme now. Let's go with Java 1.8. And Jenkins will install these tools for you, for example. And then you can say, okay, here are my steps. I want to run the build and unit tests. I delete everything from the workspace. I check out from Git, for example, and then I start my Maven, Gradle, Fastlane, Make, whatever you use for building. And then you can archive the artifacts in Jenkins, but it's better to use a proper solution like Nexus, for example. And then you can stash your build files that you need for the next step, for example, and then unstash them in the next stage. After each stage, you can have a post section which defines what should be done after this stage. And in this case, for example, you could always publish your unit tests, and then they will get stored and visualized in Jenkins. It also supports parallel execution. So you can have a stage with this parallel tag, and then, for example, test Firefox and Chrome web browser code in parallel. And they also offer a step to provide approval. So, for example, you can say that if you're on the master branch, I use this when keyword here. So only if you're on the master branch, this stage will be available to the user. So, for example, I asked here, do you really want to deploy to stage? And you can provide the permissions, for example, the admins and the tester and the project manager can do that. And if they click proceed, then this step is approved and the next stage will get started. And I think this is really where the magic happens for me in continuous delivery, is that it's not a matter of skill anymore, but it's a matter of permission. So you can, everything, how my build process works is defined in this Jenkins file. So implicit knowledge is now explicit knowledge in this Jenkins file. And I can give someone this permission but with great power comes also great responsibilities. So for example, if the project manager asks me as an ops guy, can you deploy this for me? I can now tell them, you know, why don't you do it yourself? It's only a click in the Jenkins pipeline. And then they may think about whether they really need this deployment right now, or whether it's really ready. And that's an interesting point. I also used milestones here, which mean that if one of the instances of the pipeline passes this milestone, all the older instances get canceled. For example, if I approve this instance of a pipeline, then it doesn't make sense for me to have all the other pipelines, all instances of the pipeline waiting for approval. And you could have the same for deploy to live and release, but I omitted it here. You can also have a post-build notifications, so not only the stages have a post section, but also the whole pipeline. And for example, you could say if the build fails, and it has different triggers here, so you can also have always success, unstable, changed, fixed, regression, and they're described in the documentation. You can say, for example, if this build fails, I want to send an email to everyone who has checked in, or who's a possible culprit, which means that the last build, for example, is green. Now it fails. There are 2 commits in this build, for example, from developer A and developer B. Then both of them will get an email, but developer C will not get an email. Okay, they also released Blue Ocean 1.8.2 in 16th of August. They now support sequential parallel stages. It's now also possible to restart stages for declarative pipelines, but we have to set up this keep stash policy properly and some performance improvements. So I wanted to show the live demo, but unfortunately my internet doesn't work right now, so I'll just show you the screenshots. I hope you get an impression. So if I now check in this pipeline that I just described, Jenkins will automatically detect all the branches, if there are any. And for example, here it found that on master, master is a branch with a Jenkins file, so it runs it. So it runs all the stages, and what's also very nice about this new way of visualizing it is that it automatically hides everything that is okay. So if there's not a failure in this stage, it just skips to the most current stage. And if there's not a problem in your build log output, it will just hide it, but you can collapse it. So here it asks me for my interactive input to deploy to live. And if I have the permissions to do it, I can just click on proceed, and then it will run the code in the deploy stage and deploy to my live system. Yes, you can, as I said before, you can unhide these log outputs. And what's also very nice is that it provides multi-branch support. So if you create a new branch, for example, a feature branch, then it will automatically detect whether there is a Jenkins file in there, and if there is a Jenkins file in there, it will build this feature branch. And if you delete this or if you merge this feature branch, then it also automatically gets deleted or hidden from the Jenkins GUI, which makes it very convenient because you don't have to set up any jobs and delete them after the merge. And as I said before, you can use the then keyword. For example, if I have a feature branch and I want to only release from trunk or from master, then I have the option to not offer this approval step in the feature branch using this event keyword, and then these stages automatically get skipped. So here it's only built and unit tested, and the automated acceptance tests are run, but then all the other stages are skipped. There are also some tools in Jenkins that help you with developing your pipeline. There's a Blue Ocean pipeline editor, a snippet generator, a directive generator, a replay feature, and shared libraries. And there are also others, but I don't have the time to talk about them For the others, I'll give you a short introduction. So the pipeline editor is a GUI to bootstrap your pipeline stages. So you can just click together, add a stage, add the steps, and then export the Jenkins file or store it in your SCM from Jenkins. And that's really nice. There's also a snippet generator. So as I said before, Jenkins has like 1,600 plugins. And these plugins can also provide step implementations. And using this snippet generator, you can select from all the available steps. Then you'll automatically get a form with all the options. And you can generate this pipeline script instruction and then copy it back from your to your Jenkins file. And the same is the same exists for the setting up the declarative pipelines. So for setting up the agents and all the options and environment variables. So you can just start this generator, or it's embedded in the Jenkins, and copy it back to your Jenkins file. What I also really like for development purposes is the replay feature. So if you're using Jenkins and Jenkins pipelines for the first time, you will make an error in your Jenkins file, and then you will have a lot of commits with fixing Jenkins file, fixing Jenkins file, fixing Jenkins file. And that's not the best way to do it. But there's a replay feature, and this replay feature allows you to run an instance of your pipeline again, but you can manually edit the Jenkins file. So if you make the change and then it works, you can click on replay again, copy it back to your Jenkins file, and you're all done. But this only works if your Jenkins file is valid, so if you do not have any syntax errors in there. Last but not least, there are shared libraries. And these shared libraries allow to keep your code dry. So you can write your own functions and use them in the Jenkins file. And I provided a link here, and I'll provide my slides afterwards. So what is missing? I think Jenkins has come a long way. But there's still one thing that's bugging me, and that's the support for passing variables between stages in declarative pipelines. So there's a workaround, but it's the Jenkins maintainers don't really like it. So I started a ticket and asked them. Maybe I can follow up on this one. But there's more to come. They want to increase the coverage of the editor. There will be GitLab read and write support for Jenkins file. And they also have a public roadmap, and just recently released a blog post of how they want to change Jenkins in the future. So I've provided a number of further references and information. And yeah, that's my presentation. Thank you very much. Get in touch. Thank you.